Okay, so basically, uh, the first part of this problem was to find the time it took the bullet to reach maximum height if the bullet came out of the gun at 550 meters per second. Now we know that if something is moving upwards, which is away from the surface of the earth, then the acceleration is minus 9.8 meters per second, since the object is moving away from the surface of the earth, and it's negative because it has to slow down for it to reach maximum height. So when the object reaches maximum height, its velocity is going to be 0 meters per second. So the velocity would have reduced. This reduction in velocity is what the negative in the minus 9.8 is saying. That the velocity will reduce by 9.8 meters per second every second. So at maximum height, we know the velocity is 0 meters per second. That's why we are using this expression here, v is equals to u plus gt. So at maximum height, the velocity is 0 meters per second. Then the initial velocity with which the bullet came out of the gun is 550 meters per second. Then since the bullet is going away from the surface of the earth, it is minus 9.8 meters per second. Every time a bullet goes away from the surface of the earth, the velocity is minus 9.8 meters per second. Then we are looking for the time which the bullet is going to take the bullet to reach maximum height, and that is what you're calling the rise time. So in this case, when you make the substitutions, at maximum velocity, at maximum height, the velocity will be 0 meters per second. Then the bullet with which the speed with which the bullet came out of the gun is 550 meters per second plus minus 9.8 multiplied by t rise. So you drop the units, you end up with 0 equals to 550 meters per second plus minus 9.8 multiplied by t rise. So this plus and the minus, they give you a negative. So you end up with 0 equals to 550 minus 9.8 t rise. The minus 9.8 t rise taken to the other side, you end up with 9.8 t rise equals to 550. So in this case, t rise here is going to give you 550 divided by 9.8. That's going to give you 56.1 seconds. So it takes the bullet 56.1 seconds to reach maximum height. Then in part B, we were interested in the maximum height which is actually reached by the bullet in terms of meters. So in that case, we are looking for the distance the bullet travels for it to reach maximum height. We know how much time it took. It took 56.1 seconds. And we know the velocity with which the bullet came out of the gun, which is the 550 meters per second. So in this case, you end up with S is equals to ut plus half gt squared, where S is the distance, then u is the initial velocity, t is the rise time, then half, then the g is the acceleration due to gravity. So the bullet is going away from the surface of the earth, so the acceleration is minus 9.8, then t squared, t is the rise time, which you already have here as 56.1 seconds. So we end up having this, so we work out this. So S max is going to be equals to ut plus half gt squared. So if you substitute here, you have for the u, the velocity with which the bullet comes out of the gun, that is 550 meters per second here. Then the t, which is the t rise, which is 56.1 seconds plus the half, then multiplied by the g, which is the minus 9.8 meters per second, then multiplied by the t, which is 56.1 squared. So this here, if you drop your units off, you end up with and you multiply this plus and this minus, so you end up with 550 multiplied by 56.1 minus half, then 9.8 times 56.1 squared. So if you work out this, you end up having a maximum height of 15,434 meters, which is about 15.43 kilometers. So that is how far the bullet goes up in the air. 15,434 meters. Is this clear? Are there any questions? On how we get to maximum height? Okay, if there are no questions, next we want to find out the total time of flight. Now, for you to find the total time of flight, you need to know how much time it took the bullet to reach maximum height. You also need to know how much time it took the bullet to fall from maximum height. So once you know how much time it took the bullet to reach maximum height, which is the rise time, then you also know the fall time, then you can add these two to find out what the flight time is. The flight time is the total amount of time the bullet was in the air. We already know one part, which is the rise time. We know that the rise time is 56.1 seconds. This is how much time it takes the bullet to rise from coming out of the gun all the way up to maximum height. Okay. Then we need to find the amount of time it's going to take the bullet to fall from maximum height to the ground. Assuming that, of course, we're trying to assume that probably the gun was fired from the ground going up in the air or something like that, if people can do that. Okay. So at maximum height, the velocity of the gun is 0 meters per second. At maximum height, the velocity of the gun is 0 meters per second. Then, from maximum height, when the bullet starts coming towards the surface of the earth, its velocity is going to increase. So the bullet is going to undergo some sort of acceleration. Since the velocity of the bullet is going to increase, the acceleration is going to be positive. So the velocity of the bullet increases as it comes towards the surface of the earth from maximum height. And since it's being attracted by the earth, the acceleration is going to be 9.8 meters per second. So that's what the acceleration is going to be. We also assume that the bullet is going to move through the same height as it went up. So if the height is the same, then we make this assumption here that the S-max, the distance from maximum height up to maximum height and the one through which the bullet comes through is the same, then this distance through which the bullet is going to travel will be the same as the one when it went up. It will be 15,434 meters. So this is the assumption which we make. Okay. So we can use this expression S is equals to UT plus half GT squared. In this case, we know how much the S is. That's the height to maximum height. We are assuming that the bullet moves through the same height, drops through the same amount of height as it went up. That is it's a fair assumption to make, but sometimes it might not be accurate because the person might be holding the gun in their hands and they might not be able to hold the bullet when it comes back. So there might be a difference of maybe 1 meter in the distance which has been moved. So we're just assuming that these things are the same here. So it's going to be S is equals to UT. U is the velocity of the bullet at maximum height, which we know at maximum height, every object has got a velocity of 0 meters per second. So this one we know is 0 meters per second. Then the T is the fall time. This is how much time it's going to take the bullet to fall from maximum height. That's what you're looking for. Then plus half, then G T squared. Like that. Next, we make substitutions. So for S max, we have got 15,434, which is this here. Then equals to the velocity at maximum height, which is 0 meters per second. This one multiplied by T, which is a fall time. That's what you're looking for. Then plus half. Then as the bullet is falling towards the surface of the earth, there's an acceleration there, which is 9.8. Then multiplied by another 4 times, which is what you're looking for here. So 4 times squared. So if you drop the units, you end up with 15,434 equals to 0 times T4, then plus half, then 9.8 times T4 squared, then T4 squared here. So the 0 multiplied by T4, that's going to give you 0. So you have 15,434 equals to 0 plus 0.5 multiplied by 9.8 multiplied by T4. This side here, you get your 4.9. That's what you have here. So you have 15,434 equals to 4.9 multiplied by T4 squared, which is this. Take this 4.9 T4 squared to the other side. You end up with 4.9 T4 squared equals to 15,434 Then you divide both sides by T4 by 4.9, so you end up with T4 squared is equal to 15,434 divided by 4.9. That gives you 3,149.8. Then you take the square root on both sides, so you end up with T4 equals to the square root of 3,149.8, and that gives you a T4 which is equals to 56.1 seconds. So, if we assume that the height through which the bullet falls is the same as the maximum height, then for the bullet to fall from maximum height, it's going to take 56.1 seconds. Now, this 56.1 seconds which you have here is the same as the amount of time it takes the bullet to rise to maximum height, which is here, 56.1. So if the height to maximum height, and the height through which the bullet falls are the same, what you see is that the rise time and the fall time are going to be the same. So we now have a fall time of 56.1, we have a rise time of 56.1, so we can work out the flight time. So the flight time in this case is going to be equals to the rise time plus the fall time. That's what flight time is going to be equals to. So rise time is 56.1 plus a fall time of 56.1. This is going to give us a flight time of 112.2 seconds. So this is how much time the bullet would have been in the air. Are we clear? That's how much time the bullet would have been in the air. 112.2 seconds. Any questions? Okay. Next, we move to work out the velocity with which the bullet is going to strike the ground. Now, this bullet is coming from maximum height, and at maximum height, the velocity or the initial velocity the bullet had was 0 meters per second. So here, this was the velocity of the bullet at maximum height, 0 meters per second. Then we have just found out that the bullet is going to fall through a distance when it falls from maximum height to the ground, it's going to take 56.1 seconds. So the fall time is 56.1 seconds. The initial velocity is known to be 0 meters per second. Then as the bullet is falling, it's going to move towards the surface of the earth. So the bullet is going to be moving downwards like that. So when the bullet moves downwards, the velocity of the bullet is going to increase. So there is acceleration which is happening. Since the bullet is moving downwards because of the pull of the earth, gravity, the acceleration due to gravity in this case is positive because the velocity of the bullet increases. And the value of the acceleration due to gravity is 9.8. So we use this equation, V is equals to U plus GT. This is the equation which we use, V equals to U plus GT. So with this equation, for V, that's what you're looking for. The U at maximum height, the velocity is 0 meters per second. Then plus our acceleration due to gravity, because we are moving towards the surface of the earth, from maximum height towards the surface of the earth. In this case, the velocity of our bullet will increase. So our acceleration is positive and it's with a value of 9.8 meters per second. Then the T is the fall time, which is the 56.1 seconds. So we need to substitute here. So you have V equals to 0 meters per second plus 9.8 meters per second squared times 56.1 seconds, like this. So we end up with V is equal to 0 plus 9.8, then multiplied by 56.1. So there's 0 there, then 9.8 plus 56.1, you end up with the velocity V, which is equal to 549.79. This 549.79 is roughly 550 meters per second. The 550 meters per second is the velocity with which the bullet strikes the ground. Now, this 550 meters per second, if you look at our question, is the same velocity with which the bullet left the gun. Here. The bullet leaves the gun with a muzzle velocity of 550 meters per second. So when the bullet comes back and hits the ground, it is going to have the same velocity with which the bullet left the gun. Here. So it hits the ground with this velocity. This is one of the reasons why you should never be near a place where people are firing guns. If there's a disturbance somewhere, then the police fire their guns even in the air. It is not safe for you to be in such a place, because when the bullets come back, when they fire their guns in the air, bullets go in the air. It does not mean that those bullets are gone for good. No, they will come back, because that bullet that fired in the air will reach maximum height, then it will come down. When the bullet comes down, it's going to come down with the same velocity with which it left the gun. So you can still get killed by a gun which was pointing in the air when it's shot. Okay? It doesn't mean because the police are firing their guns in the air, then it means then those guns have become less deadly. No. They can still kill you from this calculation which we have made here, or you can still get very much hurt. I think there have been reports of police guns where you hear, no, someone was at home, then the police were firing guns somewhere, then people got injured somewhere else. This is the reason why people get injured somewhere else. Because of the live ammunition which the police use, and those bullets, when they come back with very high speed, as you can see here. So, if the height is the same, through which the bullet goes up and comes down, the first thing you notice is that the rise time and the flight time are the same. The other thing which you notice is the velocity with which the bullet hits the ground. The bullet hits the ground with the same velocity with which it went up. So the gun is still very, very much deadly. Are we clear? Yes, so please, do not be where people are firing guns. If a gun is being fired, go the other side. Okay? Because you don't know who fired the gun. Alright, so this brings an end to this bit. The next bit which you have to do, I'll stop sharing a bit so that you can change screens. The next bit which we have to look at is something called projectile motion. Okay, so projectile motion. Now, projectile motion is not the same as what we just looked at. In the case that when it comes to projectile motion, the thing which has been fired, or it's a bullet, or whatever it is, or it's a rocket, or whatever it is which has been fired, it moves in two different directions at the same time under the influence of gravity. So that's the thing you have to be aware of when it comes to projectile motion. The projectile moves in two different directions at the same time. It moves horizontally, it also moves vertically. So there is moving on the horizontal side and also moving vertically. That's about projectile motion. So there's horizontal motion, there's also vertical motion. Okay? The horizontal motion of a projectile does not have any acceleration. So there's no acceleration which is happening in the horizontal motion. But there is acceleration which is happening in the vertical motion, because your projectile, remember, it has to reach maximum height. For it to reach maximum height, it means that the velocity has to reduce. So eventually the velocity has to become zero. Then after the velocity becomes zero, then it has to start increasing. So there's, when projectile is going up, the velocity reduces, meaning that in that case the acceleration is negative, minus 9.8. Then when the projectile comes down from maximum height, the velocity increases, meaning that the acceleration is positive and is plus 9.8. So when the projectile is going up and down, there is acceleration there. Okay? There is minus 9.8 when it's going up, then there's plus 9.8 when it's coming down. So there's acceleration there. So there are a couple of things you're supposed to be aware of when it comes to projectile motion and what we are interested in. Anything which executes, any object which executes projectile motion moves in two different directions at the same time. There is movement in the horizontal direction, parallel to the ground. There is also movement in the vertical direction at 90 degrees to the ground. These two motions, the horizontal motion and the vertical motion, happen at the same time. The horizontal motion is characterized by what is called uniform velocity. So in the horizontal, there is no acceleration. So whatever the velocity was in the horizontal direction, after the projectile has done whatever it's supposed to do, the velocity is going to be the same. In the vertical direction, there is acceleration. There is uniform accelerated motion. And that uniform accelerated motion is as a result of gravity. So as the projectile goes up, away from the surface of the earth, it undergoes uniform acceleration of minus 9.8 meters per second. Then as the projectile comes down, again it undergoes another uniform acceleration of plus 9.8 meters per second. So this is how you describe projectile motion. Motion where an object is moving in two different directions which are at 90 degrees to each other. So there's vertical and horizontal. These two are at 90 degrees to each other. The vertical one motion is uniform velocity, so there's no acceleration. The horizontal one is uniform velocity, there's no acceleration. The vertical one is uniform accelerated motion, there's acceleration there. The other thing you're interested in when it comes to describing projectile motion is you're interested in finding out how much time does it take your projectile to reach maximum height. That is what you call the rise time. So you want to find out how much time it takes your projectile to get to maximum height. That's the rise time. Once you find out how much time it takes your projectile to get to maximum height, the next thing you want to find out is what is the maximum height that was reached by the projectile. So you want to find the rise time, the time it takes your projectile to get to maximum height. The other thing you want to find out is the maximum height which a projectile actually reaches. Then next, you want to find how much time it takes your projectile to fall from maximum height. What is the amount of time it takes your projectile to come back from maximum height? So those are the things you're interested in. You're interested in the rise time, you're interested in the maximum height reached by the projectile, you're interested in the fall time of your projectile. Once you have the rise time and the fall time, you can always work out the flight time. The flight time is the total amount of time your projectile was in the air. As we have seen from the other example, you work out the flight time by simply adding the rise time to the fall time. Once all this has been done, the other thing you want to find out is what is the horizontal distance the projectile moves by the time it falls. Yes?
What are we supposed to use when finding the flight time? You said the rise time minus or plus the fall time?
Plus the sum. So flight time is equal to rise time plus fall time.
Okay, thank you.
Yeah. So for you to work out the flight time, you need to find out what the rise time is, the time it takes your projectile to get to maximum height. Then you also need to find out what the fall time is, the time it takes your projectile to fall from maximum height. Sometimes the rise time and fall time, like we saw in our previous example, can be the same. Other times they might not be the same, so you might have to work them out separately. Then once you have done that, then you add them, then that's going to give you your flight time. Then using this flight time, you can find out the horizontal distance the projectile moved, and this is what is called the range. So you see how to do this. Then after that, the other thing you might be interested in is the velocity with which your projectile is going to hit the ground. And this is exactly what soldiers are interested in. The faster something hits the ground, if you're a soldier, the better for your enemies. So if something is going to hit the ground slowly, most likely your enemies will survive. But if your missile or your rockets or your bullet hits the person very fast, then most likely they will not make it out alive. Okay, so these are the things we're interested in. Now, for you to be able to do all these things which you're interested in, you need to realize the first thing about a projectile is that this projectile will move in two different directions. Okay? There's a horizontal direction where the projectile is moving with constant velocity. Then there's a vertical direction where the projectile is moving with a constant acceleration of minus 9.8 or plus 9.8. Okay. So usually when it comes to a projectile problem, we will give you what is the velocity with which the projectile comes out of the gun, or it comes out of whatever it is it's being fired from. So the muzzle velocity or the launch velocity is going to be given. In our case, the launch velocity of this anti-aircraft gun fired is 550 meters per second, and it is fired at an angle of 45 degrees to the ground. The 45 degrees to the ground has been specifically chosen because that is when you can get maximum range. If the angle you're firing your gun or your tear gas gun is at 45 degrees, that is when your thing can travel the most distance. Any other angle other than that is going to result in a distance which is less. Okay. So with this 550 meters per second muzzle velocity or launch velocity at an angle of 45 degrees, we can use these two quantities to find out how much is going to be the velocity of this projectile along the x-axis and how much is going to be the velocity of this projectile along the y-axis. That is what is called the component. A component of a vector is how much that vector is along the direction of interest, in this case along the x-axis, which is the horizontal direction, and we also want to find out how much the velocity is along the vertical direction, which is the y component or the y-axis. So since u is 550 meters per second and the angle is 45 degrees, we can find how much the launch velocity or the initial velocity is along the x direction. So in this case, we're talking about ux, the initial velocity along the x direction. So that's going to be 550 meters per second multiplied by cosine 45 degrees. So this 550 meters per second times cosine 45 degrees, this is going to give you a velocity of 389 meters per second. Are we clear on how we have found how much the velocity, how much of the launch velocity is going to be along the x direction? This 389 meters per second is how much of this 550 meters per second will be along the x direction. It's just the x component. Are we clear? Okay. Next, we want to find out how much of this launch velocity is going to be along the y-axis or in the vertical direction. So that's going to be 550 meters per second multiplied by sine 45. So 550 multiplied by sine 45, that is also going to give us 389 meters per second. So this is another thing you notice at 45 degrees. At 45 degrees, whenever a projectile is fired at 45 degrees, the x component of the velocity, ux, and the y component of the velocity, uy, are the same. They have the same size. 389 meters per second, then here you've got 389 meters per second. So the components of the velocity when a projectile is fired at 45 degrees are going to be the same. Okay. So that's where they're the same. After that, things are different. Along the x direction, we said that the velocity is going to be constant. There is no acceleration. So along the x direction, the projectile has to move along the x direction, or it has to move along the horizontal direction. It also has to move in the vertical direction. But along the horizontal direction, the projectile is going to move with a constant velocity of 389 meters per second. The velocity along the x direction is not going to change because there is no acceleration in that particular direction. Are we clear? The acceleration only happens when the projectile is moving away from the surface of the earth, when it's going up, and when it's coming back from the surface of the earth. That's when acceleration happens. So in the William Lenga, your microphone, and someone else's microphone, I don't know who it is. Yeah, that was William Lenga doing the noise. So in the y direction, when your projectile moves away from the surface of the earth, it has to reach maximum height. So in the y direction, this velocity, 389 meters per second, will have to reduce. As your projectile goes up, it will have to reduce. When it reaches maximum height, the velocity of your projectile is going to be equal to 0. So that's what you're supposed to be aware of. So basically what we do, once we have found out how much is the launch velocity in the x direction, it is 389, and how much is the launch velocity in the y direction, it's 389. We concentrate on what's happening in the y direction, in the vertical direction. For the time being, we forget about what's happening in the x direction, because you can always predict what's going to happen in the x direction if things are constant. So in the x direction, the velocity is constant, but in the y direction, the velocity is not constant because there's acceleration. So in the y direction, the velocity, the initial velocity uy is 389. So we're going to use this 389 to find out the rise time. How much time does it take to get to maximum height? So by the time our projectile reaches maximum height, the velocity at maximum height is going to be 0 meters per second. It started out with a velocity of uy, which is equal to 389 meters per second. So the velocity is going to reduce from 389 meters per second to 0 meters per second, and it's going to, as it's reducing, the acceleration will be minus 9.8 meters per second. So the acceleration is minus 9.8 meters per second. The initial velocity is this, and the final velocity is going to be, this is supposed to be Vy, it's supposed to be 0 meters per second. So here we end up with V is equal to U plus GT, this. So we write this in the y direction, so you end up with Vy is equal to Uy plus GT, GT rise. So this is the initial velocity in the y direction, the acceleration, then the rise time. So we know at maximum height the velocity will be 0 meters per second, the initial velocity 389, then the g, your projectile is going up away from the surface of the earth, so your g is negative, then you're looking for the rise time. So like that, if you substitute, so you're just going to work out the rise time. We'll continue on Thursday. If you make a substitution for Vy, it's going to be 0 meters per second. The initial velocity in the y direction is 389 meters per second, then plus minus 9.8 multiplied by t rise. If you drop the units, you end up with 0 equals to 389 plus minus 9.8 t rise. This plus and the minus, they give you a negative, so you end up with 0 equals to 389 minus 9.8 t rise. You get the minus 9.8 t rise to the other side, you have 9.8 t rise equals to 389. So you divide both sides by 9.8, you end up with t rise is equal to 389 divided by 9.8. That gives you a t rise of 39.7 seconds. So in this case, it takes our projectile 39.7 seconds to reach maximum heights. Are we clear? We are only concentrating on what's happening in the y direction. We forget about what's happening in the x direction. So for our projectile to reach maximum height, it will be 39.7 seconds, which is close to 40 seconds. So you can just approximate it as 40 seconds. Do you have a class coming up at 15 hours?
No.
Okay, then I can go up to 15 hours then, if there's no class. Okay. So, this is our rise time, this is 39.7 seconds. Using this rise time, we can use the rise time to work out the maximum height. Because we know the rise time, then we know the velocity with which our thing started off, which is 389 meters per second. Then also we know that our projectile is going up. We can use that information to work out the maximum height reached by the projectile. So calculating maximum height reached by the projectile, so we can use this formula: S is equal to UT plus half GT squared. So we know rise time for a projectile to reach maximum height, it takes 39.7 seconds. Like that, we know also the initial velocity in the y direction. So our S max is going to be equal to UY is equal to T rise, UY. So S max is equal to UY, the initial velocity in the y multiplied by T rise, which is the rise time, then plus half GT squared, GT rise squared. So the UY is the initial velocity in the y, which is 389 meters per second, multiplied by T rise, which you have found as 39.7, then plus half, then the G, which is we're going up, so it's going to be negative. The G is going to cause the velocity of a projectile to become 0, so it has to be negative. So minus 9.8, then multiplied by T rise again, which is that. So we substitute with 389 meters per second plus 39.7, then plus minus 9.8, then multiplied by the 9.7 squared here. So this is what we get there. You drop the units, you have 389 times 39.7 minus 0.5 times 9.8, then 39.7 squared. If you do this, you work out this calculation, you end up with an S max of 7,720 meters. Actually, I think we should just finish this thing so that when we meet on Thursday, we are a bit behind. So I want us, by the time we meet on Thursday, we also catch up with where everybody else is, so that next week we start this uniform, Newton's laws of motion as well. So let's just finish up this. It might take us an extra 10 minutes, but I think it will be good for you to finish it up. So in this case, our rise time is 7,720 meters. So we have, maximum height is 7,720 meters. So our rise time is 39.7. Our maximum height now is 7,720. So one thing you notice is that because the velocity of the thing is the same as in our example, it is 550 meters per second. So what you notice is that because now this thing is being fired at an angle of 45 degrees, there is a change in the rise time. The rise time has reduced to 9.7. Previously, the rise time was 56.1 seconds, and our maximum height was 15,000, and now our maximum height is 7,700 and something like that. So it is basically half of what it was. Okay. With this maximum height of 7,720, you can conclude, you can assume that, which is what we assume here, you can assume that this projectile is going to fall through the same height. If the projectile falls through the same height and it reached maximum height, meaning that at maximum height its velocity was 0 meters per second, because every object at maximum height has a velocity of 0 meters per second in the y direction. Vertically, the velocity has to be 0 meters per second. That's when we conclude that you reach maximum height. So since this thing reached maximum height, and it took 39.7 seconds to do that, and the maximum height reached was 7,720 meters, then it starts to come down. When it starts to come down, the velocity is going to increase. It will not stay 0 meters per second squared, but because it's coming down, the velocity is going to increase, and when it's increasing like that, the acceleration is 9.8 meters per second. So we can assume that this thing is going to force through the same amount of height, which is 7,720. So the distance which our projectile is going to move vertically is known, since we are making the assumption that it's the same as the height through which the projectile rises. So the only thing we need to find now is the 4 time. So in this case, so we use this expression, S max is equals to ut plus half dt squared. Then, since we are only looking at what's happening in the y direction, so we are in the y direction, the distance is S max, so we assume it's going to fall through the same height as the maximum height, then equals to uy, the initial velocity at maximum height, uy, then multiplied by t4, which is the 4 time plus half, then g, the acceleration as this particular thing is falling from maximum height, then multiplied by t4 squared, this, like that. So when we substitute for S max, we have got 7,720, that's what you have here, 7,720. Then for uy at maximum velocity, the initial velocity is 0 meters per second. Then g, acceleration due to gravity as your projectile is falling from maximum height, then your g is plus 9.8, so that's positive. So when we make substitutions inside, so you end up with 7,720 meters equals to 0 meters per second squared times t4, the 4 time plus half, then 9.8, which is acceleration due to gravity, times t4 squared. When you drop the units, you end up with 7,720 equals to 0 times t4 equal plus half times 9.8 times t4 squared, like this. So 0 times t4 squared, that gives you 0. So 7,720 equals to 0 plus half times 9.8. So that's half times 9.8 is going to give you 4.9, then t4 squared, like this. So 0 plus this gives you that 4.9 t4 squared, the other side 7,720. So you get the 4.9 t4 squared to the other side. The 4.9 t4 squared equals to 7,720. Then you divide both sides by 4.9, so you end up with t4 squared equals to 7,720 divided by 4.9, which gives you 1,575.5. Then take the square root on both sides, so you end up with t4 squared is equal to the square root of 1,575.5. This gives you a 4 time of 39.7 seconds. So yes, the 4 time has reduced because the maximum height has reduced also. But the one thing which is the same here is the fact that, like in our previous example, the rise time and the 4 time have got the same value. This happens if we assume that the height to which the projectile rises and the height through which it falls are the same. If the height to maximum height and the height from maximum height to the ground are the same, then you can quickly conclude that the rise time and the 4 time are going to be the same. In this case, it's going to be 39.7 seconds. Is this clear? So this is the conclusion you can make quickly based on the fact that you know that the height to which a projectile goes up and it comes down are the same. If they are the same, then you quickly conclude that the rise time and the 4 time have to be the same. In this case, it's 39.7 seconds. Any questions? Now that we have got the rise time and 4 time, we can work out what the flight time is. The flight time, TF, is going to be equal to the rise time plus the 4 time. So the rise time is 39.7 seconds, the 4 time plus the 9.7 seconds, and this gives us a flight time TF of 79.4 seconds. This 79.4 seconds is close to 80 seconds, and that's what this graph is trying to show somewhere here. There's a graph trying to show that here. This is a flight time. So this graph, you start off from here. So your projectile is fired at 45 degrees, it goes that way, then hope it comes back up to there. That's how much time is in the air. You can see it's very close to 80 because that's 79.4. Then here you can see the maximum height to which a projectile goes. That's between 7,000 and 8,000. So that's what we had it at 7,720. Then here, the time it takes to reach that much, that is approximately 40 seconds. So you get approximately 40 seconds to get maximum height, another 40 seconds to come down like that. So this is what is called a flight path. How a projectile moves like that. Okay. And of course, this one is showing you the distance, the horizontal distance which a projectile is going to move. As it is doing this, how much distance, as time is passing, how much distance is it covering horizontal like this? Now that is what is called the range. And we're going to work out the range here. Now, the thing you need to do is that for you to work out the range, you need to know how much time your projectile has spent in the air. So flight time always has to be known if you're going to work out range. So you need flight time. Before we do the range business, we want to find out what is the velocity with which the projectile strikes the ground in the y direction. So in the y direction, when the projectile is leaving maximum height, we know the initial velocity at maximum height is 0 meters per second. Then it is going to fall through a particular through a particular distance, and it's going to take 37.9 seconds. So the fall time is also known. So we know the fall time very well. T4 is 39.7 seconds. And we know the initial velocity at maximum height, which is 0 meters per second. Then the projectile is coming towards the surface of the earth. So there is increase in velocity in the projectile. So the acceleration is positive. Since we are on earth, we know that acceleration due to gravity is 9.8. So we use this expression. V is equals to U plus GT. V, in this case, in the y direction, we end up with Vy is equals to Uy plus GT2. This, yes? There's a question?
Yeah, share the screen. We're not able to see the screen.
Oh, sorry. Must have got. Okay. So I was saying that before we work out the range, let's work out the velocity with which the projectile strikes the ground. Now, before a projectile strikes the ground, it has to come from somewhere, and it's coming from maximum height. So at maximum height, we know the velocity of a projectile at maximum height is 0 meters per second squared. So in the y direction, the initial velocity of the projectile is 0 meters per second at maximum height. So as it's coming from maximum height, the velocity of the projectile will not stay 0 meters per second, but instead it will increase. So as the velocity increases, it's going to increase at a rate of 9.8 meters per second squared. Okay? So that's the acceleration. So there's acceleration which is positive as your projectile is coming down from maximum height. We know how much time this is going to happen for. We have worked out the fall time, which is 39.7 seconds. So we can use this information to try to work out what is going to be the velocity with which our projectile will hit the ground only in the y direction. We don't have to bother about what's happening in the x direction, because in the x direction, the velocity is the same. It is still whatever it was when we left it. So all this time, after 80 seconds, along the x direction, the velocity is still the same. So we don't have to bother about that since it's constant. So in this case, so we have V is equals to U plus GT. So that's going to be Vy is equals to Uy plus GT. This T2 is supposed to be T4. So I think the next set of notes which are going to be made, so we need to make this correction here so that we don't have a 2 but we have a 4 here. So substituting for Uy for 0 meters per second squared, then for T2 which is T4, 39.7 seconds. When you do that, you end up with this. Vy is equals to 0 meters per second squared. The reason this is the velocity at maximum height, then plus the 9.8 meters per second squared, which is acceleration, then multiplied by the 4 time, which is 39.7 seconds. When you do this, you drop units, you end up with Vy equals to 0 plus 9.8 times 39.7 seconds. And when you work out this, you end up with Vy is equals to 389 meters per second. So in this case, our projectile along the y direction hits the ground with the velocity with which it went up with along the y direction, which is 389 meters per second. So here what you see is that your Uy, which is 389 meters per second, when the projectile is going up, is the same velocity equals to Vy, is the same velocity with which the projectile hits the ground. So it is actually sound to assume that if the height through which the projectile goes up and the height through which the projectile comes down is the same, then the velocity with which it went up and the velocity with which it comes down are going to be the same. In this case, it's going to be 389 meters per second. Are we clear? So there are certain things you have to be aware of. If the height going up and the height coming down are the same, then the rise time and the fall time are going to be the same. Then the velocity with which the projectile goes up and the velocity with which the projectile strikes the ground are going to be the same. So those things are the same. Is that clear? Is this clear? Okay, I'm not receiving any confirmation. I'll move forward. The range. For you to work out how far a projectile is going to travel horizontally, you work, basically, that's what the range is. For you to get the range, you need to multiply what is the velocity of the projectile along the x direction multiplied by the flight time. So along the x direction, you have to remember that there is no acceleration. So along the x direction, the initial velocity ux and the final velocity vx are the same because there is no acceleration. So for you to get the range, you multiply ux, the velocity of the projectile along the x direction, along the horizontal direction, multiplied by the flight time. So the velocity is 389 meters per second times the flight time, which is 79.4 seconds. So 389 times 79.4 seconds, that gives you a range of 30,886.6. Excuse me? Hello? What is it? Okay, so the range is 30,886.6 meters. So that is approximately 30.9 kilometers. So these things can move very, very long distances. So this is how you find the range. You multiply the velocity along the x direction times the flight time. So for you to work out the range, you always need to know how much time this particular projectile spent in the air. If you know how much time it spent in the air, then you multiply that times the velocity of that particular projectile along the x direction, then you are going to get yourself a value of range. Are we clear? Last but not least is you want to work out the velocity with which the projectile is going to strike the ground. We know that when in the y direction, the velocity is 389 meters per second, and also along the x direction, the final velocity is 389 meters per second. So these Vx and Vy, these are the final velocity components. The final velocity along the x component, the final velocity along the y component. So these are components, and if you've got components of a vector, Vx is equal to 389 meters per second and Vy equals to 389 meters per second, then you can use this expression to find out how much that vector is. You work out the magnitude. So V is going to be equal to the square root of Vx squared plus Vy squared, and that gives you 389 meters per second squared plus 389, the whole thing squared, then the square root. That gives you a velocity of 550 meters per second. So again, even in this example, despite the thing being fired at an angle, the velocity with which this thing is going to hit the ground is going to be the same as the velocity with which this thing left the gun. So there is no difference really whether someone is shooting a gun at you at point blank range or whether they're shooting a gun at you at a distance. The speed of the bullet is not going to reduce. It is going to be the same. That's why I was saying to say, if there is a disturbance, a public disturbance, and the police are firing guns, do not think that being at a distance while watching this thing will save you. There are people who have been killed at a very, very long distance because policemen fired a gun. The speed of the bullet won't reduce. When it hits you, it is the same as it came out from the gun. There is no difference. Are we clear? Okay, so this is the end of our lecture for today. So I'll see you on Thursday morning so that we can look at lecture 3D, equations of uniformly accelerated motion. Hopefully we'll finish that so that we catch up with where people are. Because I think people have started looking at Newton's laws of motion, but some people are finished. I'm not sure. Some people are moving much faster. Yeah. Any questions? Okay, if there are no questions, we'll come to the end. The video will be uploaded to YouTube as usual. Okay? See you on Thursday.